This is Techzine Talks on Tour, the podcast about enterprise technology that brings you IT insights and analyses from events all around the globe. We cover everything, everywhere. Visit techzine.eu for more information, and don't forget to subscribe to this podcast.
Welcome to this new episode of Techzine Talks on Tour. I'm at Vertiv's Driving Innovation event in Bologna, Italy, and I'm here with Arturo de Filippi. He's the offering director, large power for Vertiv. Welcome to the show, Arturo.
Thank you.
Okay, so we saw a lot of things today about powering the age of AI, right? Which is a hot topic at the moment, especially for a company like Vertiv, I would imagine. So one key takeaway that I had, based on the keynotes that we had and the sort of conversations that we had, is sort of dynamic. That's stuck in my head for some reason, right?
Absolutely. So first of all, hi everyone, and thanks for. I'm really delighted to be here, and absolutely you are spot on. So you say the word that we have been mentioning multiple times in today, and also in another event that we had just 2 days ago. It's dynamic. So dynamic is something that we associate to the evolving challenges, but also developments that are happening around the data centers. So I'm in charge for the product management or offering for large power, and our customers are mainly those that are deploying data centers, because our products are 500 kVA and going up
so 500 kilovolt.
Yeah, from 500 kilowatt ampere up to 2.5 megawatt. We have currently also products that are getting even more than that, to 3 megawatt, and therefore our target of customers is data center. And we have seen some numbers today of what are the projections about how much the power can be absorbed and utilized by data centers and critical infrastructure from now up to 2030, and it's huge, it's massive, and that is why we will need to make sure that our equipment is going to be dynamic enough to support those.
So I saw some numbers, 300 to 500 kilowatts per rack in about before 2030 or something like that, and we're at 150 now or something.
We are even less right now. So actually, right now when we go to
we're at 50, power, right?
Yeah. Yes, we are. We don't get depending on the area of the world. So in America, this let's call it AI boom is probably already having the highest level right now, whereas in Asia and EMEA, it still need to be there, and we are seeing currently still installation where the rack power density is below 50 kilowatt, but it's coming also here, and you are right, the projections that have been made were are considering hundreds of kilowatt per rack.
So basically you have what the likes of NVIDIA are doing with higher densities, you basically have to do the same.
Absolutely.
But from a power and a UPS kind of perspective.
Yeah, we will need to support the critical infrastructure. So we as Vertiv, we have been always supporting critical infrastructures, and we will continue to do so, not just for the traditional data center, but even more for the AI data center. And back to your questions about the dynamic, the load, especially for AI application right now, it's much more dynamic as traditional data center, where we're more or less set around traditional loads, traditional stationary loads. Right now it's very dynamic, and as consequence we will need to be able to adapt on that. And then of course our features are also, in some cases, operating modes are having dynamic in there, without going to detail.
But can you, concretely, can you run AI workloads at the moment on existing power and backup for UPS solutions? I would say yes, right?
I'm glad that you asked, because the answer is yes. Of course, this is evolving right now. So if we probably in 1 week from now, we will have some other information about the AI workloads profile. And they are challenging to be managed by the power train we define, because we are Vertiv, we can provide all equipment for the entire
Yeah,
powertrain.
you talk about the powertrain and all cars on the powertrain. Maybe sort of so what you're saying is you deliver everything that has to do with power from the grid all the way up to the server. Basically.
Yes, and pretty funny. We are in the car valley here, so we have a lot of great cars, and of course our products can be classified as the same. You're right. So we are covering the entire powertrain, meaning all the power. I'm now speaking specifically for the power equipment, everything that goes from the grid to the chip. And but all this equipment will be affected by the variability of the workloads, and as such we need to be able to support them and to provide most important guidance to those that are consultants, but even customers that are basically trying to understand what happens to the center in that case.
So getting back to the running AI workload on existing solutions, which is possible, obviously, but is it something that customers need to sort of reassess and look at replacing because of evolving needs when it comes to AI workloads, or how does that work?
Yeah, good one. We have been, I would say, lucky, not clever, lucky enough to design since many years already equipment that is able to withstand the most challenging and demanding load profiles. Yeah. Our products have already overload capabilities, which are very, we say, higher than most of our competitors.
Yeah, we did a tour of the facilities today, and I think somebody, if I remember correctly, somebody said that they tested at 150%.
That's correct.
So 50% overload for
50% overload. So instead of 1 megawatt, if you have a megawatt load, we can do 1.5 for 1 minute, and we have been having already this capability on the existing products. Now, so the answer is yes. On new products that we are launching right now, we are also performing some firmware adjustments such that we can support operating conditions that may arise, because let's be honest on that. The workloads profile are changing all the time, and there's no one profile that we have to support. We need to be able to support all of them, also with the help of batteries when it's possible.
So, and just to be clear, it's not only about more power, right? It's also about the form of the world, or the behavior of the workload, maybe is a better word. Which has AI workloads usually have lots of spikes. It's very spiky, so it's very. Sometimes it needs a lot, and sometimes it doesn't need all that much.
Yeah,
that's also very. But that's something you can't really do maybe very well with the existing solutions, and that's something that you're actually working on, or.
So right now with the existing, we can, because there are many two aspects of this spiky or erratic load. One is the overload, which is more power, as we were saying. The other one is the variability in the very short time. So what is the difference between the existing products and the new products? So the existing products can support the overload very well. As per the variability in the very short time, that's something that they can do. But of course, it's a matter of firmware calibration on how much you see that variation, how quickly you see that variation. Yeah. And on the new products, we are certainly emphasizing that aspect. And but at the end, we have existing products that will be used for the AI application. So eventually, we will need to have also this feature that we are driving on new products. We may need to have them also.
Because I was wondering, also based on sort of a parallel with NVIDIA, that there are many parallels between what you're doing. I mean, does it also mean that maybe there's more focus on the software side of things to keep all this running, or is it still sort of mainly a hardware play?
So it's both. The firmware is certainly so on the existing unit. The hardware is already there.
Yeah.
So the extra hardware that may be needed to support this variability is not in the UPS itself. It's out of that. Because maybe, for instance, additional energy storage that you may need to provide power for the spiky loads. So, for instance, like we touched also the aspect of dynamic grid support today, where or peak shaving, where probably the batteries are expected to give the energy needed when the grid is not there. That's more or less the same for the variability of the AI loads. If the grid operator does not want to see that very huge step load, so batteries can support on that. So the additional hardware may most likely be on that side, whereas the firmware is something that probably will take most of the work on our side, which is the power converter side.
Yeah. So, and how about, I mean, we talked about UPSs, right, basically. I also got the impression that the role of the UPS is changing, right? So, because from my experience, following this market for quite some time, UPSs are there for if there's something up and you need power to keep running. You have a UPS, right? But I also heard from the man from Sweden, from the data center, that they're using their UPSs also for sort of smart grid how does that work?
Yeah, and we are actually embracing this change, and in fact, so our product line has recently been renamed as large power converter, but because we are not just now speaking about UPS, because the role of UPS is changing into power converter, and this power converter does no longer only provide backup power and power quality, that are two main features that the UPS has traditionally been providing, but can also provide something more, can enable, and we have actually mentioned that in the today's discussion, can enable the interface with new energy sources, and also can enable services like fast frequency response or peak shaving. Yeah. So in that case, probably the power converter or power center, let's say, will enable some of the services that you won't have on a, let's say, standard UPS. And like the case in Sweden, they can export power into the grid and get revenues for that, even if when they have no load.
That's actually quite interesting because, as you also know, obviously, data centers sort of have a bad reputation when it comes to power, being very power hungry, and obviously when you're talking about megawatt kind of deployments, they do use a lot of power. I mean, you can't really argue against that. But
get away with that.
No, but if you do it like this, if you actually use them to make the grid smarter, then they have a sort of an extra reason to exist, and so putting a positive spin basically on.
Absolutely. Let's see the glass half full. No?
Yeah.
Because I agree. So. We have been lucky today because one of the panelists was Stefan, and so we know that in Nordics is very ahead in terms of decarbonization, sustainability.
I know last year you had also someone from a data center in Sweden when we talked about the timber mod. I mean, that was also somebody. So it sounds like you do have customers outside of Sweden, right?
Absolutely. We do have them outside. They will still need to get there for what concerns decarbonization and sustainability, but it's all there. Yeah. And they can certainly, basically, they want to provide also a contribution, so some additional services to the municipality. So Stefan was mentioning district heating. So they said that their data center, they actually the municipality is asking them to build more data centers because they need them. Yeah. They need for district heating and for also the energy use. And of course for the data processing.
There's I come from the Netherlands, and I have district heating at home as well. But there's no room for a data center next to where I live, right? So it's obviously Sweden has lots of room for extra data centers, and they have thermal,
they have
hydroelectric stuff.
Power, they can generate.
So and it's relatively cold, so it's easier to cool.
Absolutely.
So it's not something that you can do everywhere.
Right.
But I do think, at least from my perspective, I'm curious to hear what you think about this. Is that saying no to new data centers, like some countries are doing, and I think in the Netherlands around Amsterdam, there's also sort of that may make sense in the short run, but in the long run, the workloads are not going to go away, right?
Absolutely.
So especially with AI coming up, they're only going to get more and more intensive.
Yeah.
So how do you get the compute for your workloads as an organization or as whatever if you're not allowed to build, so you're going to do it yourself, and you build many smaller probably.
Absolutely.
That doesn't solve anything, does it?
So I fully agree. Also, it's not that we know that these data centers are absorbing power, and the transition to alternative energies, to renewables, probably is proceeding slowly than we thought, as well as also the adoption of hydrogen, for instance, for new power. But it's also true that we will need data, and now more and more with AI, many applications are going to be using the AI, and also a lot of it's not just data centers, it's also a lot of enterprises, C&I, so Carlos, a lot of different customers that were not engaged there. So we have been discussing a lot about power availability. We know that in the US it's probably much easier to get power compared to some area of Europe where regulations are really demanding.
And in the US, probably that's also the region where you see the demand for the highest capacity units as well, right? So the 2.5 megawatts and all that and up, that's usually for the US, right? Not necessarily for...
No, that's something. So in the power, we define the power block, probably that is there. Already using a power block 2.5 megawatt. Here we are seeing more 3 megawatt in some cases, but 2 megawatt is most common. We are following, of course, this demand, but yes, in the US it's easier to get power for new sites, and also there are a lot of space more, of course. So it's something that. But recently in Ireland we are seeing a lot of. So the grid operator in Ireland saying, no, I won't give you any more power. But at the same time, there's the use of a lot of gas turbines. So.
Let's just move over to what this means for customers, other than maybe rethinking their power needs and all that, because I would imagine you, as a customer, you also need to sort of do some thinking beforehand before you actually go for this new powering AI kind of kind of phase. Yes. So what are the things that they need to sort of think about?
Well, one of the topics that we covered today was the speed of deployment, because it's possible that most of the center owners are designing now equipment that will probably see the light in 2-3 years. And we heard Francesco that was mentioning that. This means that they will need to be ready to get all the regulatory and everything in place, and then start doing something else. But then once they get that, they will need to have the equipment fast enough. And for that, we are actually try to make sure that we as Vertiv can also support in the fast deployment of the infrastructure through the use of integrated services, integrated equipment. We saw the integration of UPS with switchgear, with power modules, skid. So on our side, we will support this large deployment in the short term by being quick in reacting.
So it's going to be more integrated, more converged, maybe, if for want of a better word. Because
there are two reasons for that. One is the speed of deployment, and the second is we have been hearing a lot about the word densification today. So sometimes massification, densification. So basically meaning same as it is happening at rack level. So more equipment in less space. Very, very simplifying that. And that is also something that we want to do with these integrated equipment.
Well, on the one hand, that makes sense, but on the other hand, if data centers are already densifying, if that's a word,
that's a word,
densifying in their sort of server area, so with the GPUs and all that stuff, is it really necessary to also densify in the power? Because they're gonna have more room. Because they may even just close off half the data center because they have there's so much denser. Then it would also make sense. Look, let's just do it the old-fashioned way because we have room to spare now anyway.
Absolutely. That's a very good argument, and I guess that also because probably with liquid cooling, they will save even more space compared to traditional one. And that's why in this case, for existing infrastructures, we don't think that this will be probably this integration densification will be probably the priority number one. But for the existing ones, where probably they want to have in new space, much more power. That is where.
If you go greenfield, then
that's correct.
Then this is the better
we will
approach.
diversify in that case. Absolutely.
Yeah. So that's something that they need to think of. But do they need to prepare their kind of their environment for this new type of power solutions, or how does that? I mean, they need
So we are seeing it, even if we are not data center, we are supplying equipment to data centers and other critical infrastructure. But if you have seen the customer witness test area, so we had to expand. Couple of years ago from the current power for the existing capacity to additional megawatt, and it was very difficult to get that additional megawatt from the
grid
utility or from the grid.
Yeah.
So I don't want even to imagine what they may face if they want to start a new campus of 16 20 megawatt. So they will for sure need to check that part and probably build in areas where this power is available. But it's also true that we are seeing probably some cities, countries that are slowing down a little bit. So we know in Ireland, for instance, there are not so many data centers, but we have heard that in Milan, in Italy, they are going to build a lot of data centers. So I guess that what they are doing, and that's why they are expanding a lot. We have seen some, we have heard about some pipeline or extended pipeline from their side as well. Also, Philip today was mentioning that he has been in Asia. So, global. There will be more global customers that are going to be here, and also there was Carlo. I was mentioning also others.
But especially in Europe, some areas of Europe, this can be quite challenging to prepare for, right?
It is.
Yeah, but on the other hand, we need to do it. So, but there's also something to be said for most AI workloads aren't necessarily very latency heavy anyway.
Yeah.
So it doesn't really matter where you run them. If obviously rules and regulations aside, which has a big impact as well. So maybe running them somewhere where they can still build data centers makes sense.
Yes. Also because now we are seeing, we are preparing for the worst. Also when we speak about workloads, we go overload, variability, but we will see. In the real installation.
And from a practical perspective, I've always wondered because when you power down for a test, for example, and then you have to pick it up with your UPSs, or does that also have an impact on how you do that from when you're supporting AI workloads, especially, because I've heard that powering up a big data center with massive AI workloads and huge numbers of GPUs, you can't just flick a switch and power up everything at the same time, right? So that's something that you need to address in your solutions as well.
Yeah, absolutely.
I've heard the analogy that it's like starting a jet engine, so a little bit at a time, and then.
Yes, that should be. It's more or less like we heard about some fuel cells that were running in models, and also they had to start up one at a time. I guess the main reason for that, based on what we have heard, first it depends on how many racks you have and how they are synchronized. So at the end, it's all the synchronization. But of course, the load profile on how we are seeing that may have. As soon as they start, let's say, as we on, a peak. And this peak can get up to 150% more or less. So this peak may be managed by the PSU or even by direct themselves, but may not. That's why to avoid that all these racks get the same peak of power at the same time, I agree that having a kind of offset between the starting of all of them may be helpful.
But that's not something that you can integrate in your products, right? Because that's something that the data centers need to arrange themselves.
Yes, they will need to basically, and back to what Carlo was mentioning, they may try to work on the firmware side, like they've done so far, in order to optimize the synchronization between the.
But you can work together on this, right? So
absolutely, that's why we are partnering with that.
You have a big history in power. And NVIDIA doesn't necessarily have that, right? So they can learn from your expertise.
Yes, that's why we are partnering also, because they asked us to indicate how we can support them to manage these workloads.
Yeah.
And support means to look at the old pieces of equipment and see what happens, and this is one of the aspects that we are doing with them.
Right, then the last point, and then I think we have to go and visit the Leonardo supercomputer, which I'm quite excited about. It's always nice to visit
Absolutely,
one of those places. Renewable. I heard some about it today, but it's not necessarily a big topic at the moment because obviously there are a different focus. But what's the role of renewable in all of this? Is renewable stable enough to actually play part in this sort of UPS landscape?
So that's I guess that these we have been debating about that. You are right. A couple of years ago, that was the main focus. It is, of course, for now, but now it has been kind of surpassed by the AI and everything.
No, it wasn't the focus of today. It's fine.
Yeah, it was the focus of today. But they can certainly contribute. I really wish, like everyone in the room today, that they may contribute more because, but at the end, we will need to accept that you can add equipment. For instance, if you want to have more solar, you will need to have some energy storage that is going to be managing that additional energy. So if the problem is the space, you will need to have panels, you will need to have battery energy storage system, you will need to have probably some wind. So that goes a little bit in contrast with the demand for, densification and so on. But that does not necessarily need to be in the same area of the data center. So we have also spoken about the bring your own power, meaning there should be power at site. This power generation at site does not necessarily need to be in the same site, but should be close enough to that. So my opinion, and that was confirmed by the panelists today, was yes, they will play a role, a very important role. As per the stability, that is where the grid support that we are promoting comes in.
Because then you get, because I heard from the guy from Sweden, Stefan.
Yes.
He talked about the requirements. I think it was 49.9 between 49.9 and 50.1.
Absolutely. So they can intervene and they can support the grid in the very short time. Yeah. And this is something that we can do with our EPS.
But then obviously, and that to your point, renewable or solar is not really fit for that purpose, right? Not yet, at least.
It is indirect because
maybe it needs an extra step.
Renewables they get into the grid. So the grid frequency when they are intermittent renewables. So when they are down, the grid is in under frequency, and that is where this support from the grid may come. But of course, that's something that we are seeing now on a few areas of Europe. That will need to be extended everywhere else in the world.
All right. I think we're out of time. We have to visit the supercomputer, obviously. So thank you very much for. I think it was a very interesting conversation. Thank you very much for joining.
Thank you very much.
Thanks so much for tuning in to this episode of Techzine Talks on Tour. If you're enjoying the show, please feel free to rate, subscribe, and leave a review wherever you listen to your podcasts. That helps others find the show, and we greatly appreciate it. If you'd like more information, please feel free to visit techzine.eu, where we cover everything, everywhere. Thanks again for listening, and we hope you'll join us again on the next episode of Techzine Talks on Tour.